Hi, I'm Kian, and today I want to show you how to find if a series converges or diverges. So if you have this series as an example, we have a sum from 3 to infinity of 3 over n squared minus 3n plus 2. So when we think about this series, we can't actually use any of the tests like divergence tests for divergence, alternating series tests because this is not alternating, the limit comparison test, direct comparison test, or we can't use any of these. But think about it. If we want to integrate this function, can we integrate it? The answer is yes, because the denominator is actually factorable and we can use partial fraction decomposition to integrate it. But what are the conditions for integral tests? So if you want to use the integral test, I write it as IT. The integral tests have three conditions. One is that the function should be continuous over that interval. The other is the function should be positive over that interval. And the third one is that the function should be decreasing. If we actually graph this function, we definitely see that this is decreasing over 3 to infinity. And it's definitely positive. If you plug in values, it's always positive. And also it's continuous because there's no point of discontinuity. And if you actually want to find the asymptotes, which are the point of discontinuity, if you factor out the denominator, the point of discontinuity are at 2 or and 1, which are not actually in the interval of the series, because the interval is from 3 to infinity. So we have no point of discontinuity, which means it is continuous over the interval. So now we can actually go ahead and integrate it. But first of all, we can't integrate the variable n. So instead of n, I'm going to use the variable x, which we usually use for integrating. So I'm going to check the integral. I'm going to check for convergence. And how I'm going to check it is that I'm going to integrate. I'm going to take the integral from 3 to infinity. I'm going to put the 3 out of the integral because it's easier to not make a mistake. And then we have 1 over. And then I'm going to factor out n squared, actually x squared, sorry, minus 3x plus 2 as x minus 2 times x minus 1. And now how do we integrate this? So let me put also the dx. So we can use partial fraction decomposition. And so this would be equal to the integral from 3 to infinity. And then for doing partial fraction decomposition, we can use the cover-up method. So we have a over x minus 2 plus some constant b over x minus 1. This is always doable for linear factors when you have just x minus 1, the coefficient of x is 1, b over x minus 1. So for cover-up methods, we can actually cover up, for example, x minus 2, set it equal to 0, and then solve it, and then put the 2 in the other factor of this expression. So x minus 2 is x is equal to 2 to make it 0, and then 2 minus 1 is 1, so actually the a value is just 1. Same with x minus 1, set it equal to 0, we get x is equal to 1, put it in this case here, we get negative 1 for b. So what do we get? So if we calculate the integral, we just get 1 over x minus 2, its integral is just natural log of absolute value of x minus 2, and I put absolute value because there might be some negative values. I put absolute value for making sure. And we have minus 1 over x minus 1 is its integral is natural log of absolute value of x minus 1 again. And then because we have a subtraction by the properties of natural log, we can actually write this as natural log of absolute value of x minus 2 over x minus 1. Now, what we should do now is just evaluate this integral from 3 to infinity. Okay, so evaluating it from, so let me write it again here, natural log of absolute value of x minus 2 over x minus 1, and then from we have 3 to infinity. Evaluating this at infinity, first of all, we should take the limit of the inside of a natural log. Taking the limit is just 1 and ln of 1, because we can't actually evaluate something at infinity. Infinity is an actual number. We should take the limit, actually. And when we take the limit, this is just a 1, so natural log of 1 is just 0. So the first part of the answer we get 0. And then minus, when we put 3, we get 1 over 2. So we get natural log of 1 over 2. So for our final answer, we just get, because we had a 3 outside of this integral, we just get 3, negative 3 times natural log of 1 over 2. And now, but we have to say that because this integral goes to a finite value, which means the integral converges. So now we can make a conclusion. So I'm going to write this as in a different color. So our conclusion is that the series from n equals to 1 to infinity, and then the original series is just 3, I'll write it here, over n squared minus 3n plus 2 actually converges by the integral test. By integral test. And that's it for this video. Thanks for watching. Hope you enjoyed